Hello, folks. It has been quite a while. Like Lars says, long time no see. Rahul says hi as well. I'm glad you guys all didn't forget about this and the book club and everything like that. It's good to have you. It's good to have you all back. Um, yeah, on my end, it's been a pretty wild last month. I ended up taking three trips actually. One for an open source conference with NumFocus, where we talked about a lot of the package maintainers like myself got together, and we just chatted about what the next years of open source would look like, how we can develop communities. So really good time meeting the NumPy folks and the SciPy folks and Jupyter folks and all these technologies that we use. Then I ended up going to a surprise wedding, and then also went to Europe to meet my colleagues at Google for the first time. But now we're back on the book club. Last couple chapters we have here, actually just three more, I believe, if we don't count the conclusion. So good to see you all. As always, if there's anything you want to chat about, throw it in the chat box, and we will get to it. But if not, I will get straight into the presentation. Virtual window. All right, we'll talk about this webpage in a second. Looks like we have Rahul and Lars. If anybody else is on, let me know as well. Always fun to see who is available. But all right, here we go. Today we're going to talk about panel data. So let me know if you read this chapter. Hopefully you did. We had extra time to read this chapter, and it was a particularly short one. So, and we have Fadik. Awesome. So, let me know if you read this chapter. It's quite an interesting one. It's actually got a lot of applicability outside of causal inference. It's quite, it's this sort of panel data idea is something that you'll find in many areas of machine learning. From neural nets to the Bayesian stuff, which we'll talk about in a second. So it's, in my opinion, definitely worth looking into and learning, because you're going to see this come up over and over and over again. Oh, so as always, let's go through our agenda. Let me turn my webcam on so you can see me. Thank you all for being here. Again, especially want to thank everybody, because it's been a minute, but appreciate you all sticking through with this. We'll go through our traditional chapter overview. This week will be a little shorter because the concepts are much more straightforward than some of the other chapters we've had in the past, and it was a shorter chapter to begin with. And then I just want to preview a new chapter, a new format for next week. Somebody had proposed something, so we'll talk about that at the very end in light detail. So, chapter overview. Again, panel data. We're going to talk about three topics that I thought were the most relevant in this particular chapter, which were fixed effects, mixed effects, and random effects. The chapter only says fixed effects, but we'll talk about the other two terms that I'm bringing in from other knowledge that I have. We'll talk about Bayesian hierarchical models. So the chapter doesn't talk about this at all, but like I mentioned previously, it's this sort of panel data idea where you see the same observation longitudinally through time comes up so often in so many different areas of machine learning that I want to talk about the Bayesian version of that. And then we'll talk about the example that was brought up at the end, which was the panel data for sex workers, which Scott had studied over a number of years. As always, we have the most important picture, and this one is fairly obvious. It's these panel data DAG. So let's see if you can see my mouse. We'll dig into this DAG more. It's the most complicated DAG that we've seen so far, but this is it. This is the one takeaway picture that I would take from this chapter. Good morning, Chad, and good morning, Julio. So always want to do a quote. One of the most important tools in causal inference is the panel data estimator. And I've mentioned this 3 times now, but I'm going to say it again. It's actually one of the most common that I keep seeing over and over across all sorts of applications in the data space, from Bayesian inference, which we're going to talk about in a second. You see it in neural networks, particularly recurrent neural networks and things like that, where there's some sort of fixed structure. You see it a lot in traditional longitudinal studies that happen over time, just to measure correlations over time. I've seen this data structure in what's called hidden Markov models, where there's sort of latent states that can affect transition probability. So it just keeps coming up over and over and over. So well worth understanding all the different ways this type of data can be used, because if you ever have this type of data, there are multiple ways that you can reuse this panel data concept. Well, let's talk about fixed effects, mixed effects, and random effects first. I should have put a comma here. It's not fixed mixed, but fixed comma mixed comma random effects. So here's the idea. Some things change over time and some things don't. There you go. See? Some things change and some things don't. This is a commonality in life. You just see this happen all the time, right? So something that changes over time is somebody's income earning level, let's say, like as they're 20 and they're 30 and they're 40. But where they were born, let's say what zip code they were born in, or what country, or later on, as we'll see in the sex worker example, what their ethnicity is, that doesn't change. That's a fixed effect. So you have this thing that changes, the Y1, Y2, Y3. You might also have some other things that change with it. So maybe somebody, their age grows, okay? But there's some things that don't change. And this pattern happens all the time. You can have it with customers, right? You can have where a customer came in from, and then over time what their spending habits were, where a customer is located. This was super common at Sweetgreen, for instance. We'll talk about assumptions in a second, but we assume that a customer in New York just would stay in New York, for instance. If we can make that assumption that was their geographic boundary, then we could check their spending habits over time. And then the important one here is that there's a series of unobservables that don't change over time. So assumptions will come in at the end. Or actually, maybe I took out the assumptions slide, but there's some assumptions that the unobserved factors don't change over time as well. But if you can make these assumptions, you can start to do a lot. The reason this DAG is important is it clearly lays out what the assumptions are, that there is a series of there's a series of observables that change. There's a series of covariates that change. There are some covariates that don't change, but influence these other ones. And then there's the unobserved factors that you're not including in your data also don't change. A lot of words there. Let me know if any of that made sense. In the chapter, there were 3 estimators that were brought up. I should have said 3 equations. I could swap out the word estimator. So you see, Scott had talked about the pooled ordinary least squares regression, and it didn't have the mu term in the middle, but it changed over time. Fixed effects estimator, which we'll talk about in a second. And then this one didn't have a bold title, but it was the demeaned variable estimator here at the end. So these are 3 ways of looking at the data. And when we get to the sex workers example, you'll see that they give you different results by relaxing or including different assumptions. Now, I'm not going to go into detail of these estimators because they're explained so well in the chapter, but I do want to bring up a topic outside of the chapter because I figured that'd be the most interesting for this book club, since you can always read the book to see what's in it. And I'm going to pick a quote from my book because I can do that. So you're going to see these terms, fixed, random, and mixed effects a lot. And quite frankly, depending on the context, they can mean very different things. Now, the good news is in the Causal Inference Mixtape, Scott explains these extremely well. So we know exactly what random and fixed effects and mixed effects are. But this won't always be the case. I'm going to link this Gelman blog post, which is this kind of the source for this. I'll put that right in there. There's just, depending on the researcher, there's different, the same word means different things. So you really just have to be careful that you understand what's happening. The good news, again, is in our case, Scott explains it really well. So the fixed effects, what he's talking about, are things that are fixed, as the name implies. And his equations specifically detail what those are. But my caution is if you go read somebody else's news article or paper or something like that, and it also says fixed effects, just be aware that it might mean something subtly different. So that's my quick one on estimators, fixed, mixed, and effects. Let's now talk about Bayesian hierarchical models. And I'll point out, since it's been a while, as always, if you have any questions, just throw them in the chat. I'm happy to pause and take them. We don't have to wait to the end for the Q&A. So outside of this chapter, what this reminded me of a lot was Bayesian hierarchical models. And I want to bring them up for two reasons. One is I just want to make you guys aware of them if you already aren't familiar with them. And to point out the similarities in the model construction. But then I also just want to briefly talk about the inference methods because as we saw in the chapter, the inference methods derived took a lot of algebra. And one nice thing about Bayesian inference, especially these days, is with MCMC, you don't have to worry too much about model structure when you're doing inference. So I'll explain that more a little bit at the end. But let's talk about unpooled, pooled, and hierarchical parameters first. So as we saw earlier, there's pooled ordinary least squares regression, where you put everything together and you estimate a particular term. I believe in this one it was both D and Enya. Not Enya. Wow, I'm forgetting my Greek letters. Whatever that N is. If we start with the basics, let's say we had panel data for, we'll pick the sex workers example because that comes up later, where there's 4 observations per unit. So they were in the sex workers example. Scott mentioned that every individual brought up 4 different experiences. What an unpooled parameter estimate would be you just ignore that they all came from the same person. You would just say if we had 5 people, we have 20 data points. Doesn't matter which data point belongs to which person. We're just going to estimate, we're going to regress for each sort of observation on its own. So there's 5 people, there's 4 data points per person, which leads to 20 data points, and you estimate an individual parameter. Or you have a row item for each one, there's no connection between them. That's an unpooled parameter. Now the other extreme, which is what Scott brings up in his example, is what's called a pooled estimator, where you say that everything for everybody belongs to one particular group. So you're just estimating one effect, and you're saying it affects all the groups equally. In Bayesian modeling, and I believe this was implied in the chapter though with the ideas of clusters, but there's another thing you can do, which is you can say that all the groups are related, but the individual observations aren't fixed to the same parameter. So in this case, what could happen is that there'd be one sort of distribution up at the top that then controls the parameters, which then have their own variation, which goes down to the groups. This is a tough explanation for a quick live stream, so I will throw in a link for my book where I talk specifically much more about this. But an idea would be, the way I use this, say, in practice at Sweetgreen, which is sort of like panel data, was that there was the company level. The company level affects the parameters for the region level, and the region level affects the parameters for the individual store level. So you have, let's say, Sweetgreen, New York, and then you have 2 stores in New York. And then you have Sweetgreen, Los Angeles, and you have 3 stores in Los Angeles. And in this way, you can still get individual coefficient estimates for each individual location, each region, but then also include the effect of the company as a whole. The reason I bring this up in panel data is if you look at it, it's this. You see, it's the same sort of idea. There's a latent structure here. There's different times, and this affects that, which then affects that. I'm not saying I've done the total research on this, but that's, again, this panel data structure reminds me of that, which is why I bring that up here. An example that we have in the PyMC docs is the radon model. So, in short, if you wanted to estimate what the radon level would be in different basements in Minnesota, there's the effect of the state, there's the effect of the county, and then there's the effect of the basement itself. I'll link to the example and let you guys look at it. Of course, if there's any questions, we can talk about it at the end, or there's always the discourse. So the last bit that was in this chapter was the panel data for sex workers. This was the biggest example in this chapter. Clearly one that Scott was quite passionate about, given that it was his research, and I thought it was quite well done. So here was the explanation of it. In short, if you didn't read the chapter, Scott had asked various online sex workers to input, let's say, their fixed effects, like their ethnicity and things like that, and then also 4 data points for their last 4 encounters or sessions, and then some of the data about that. So in this case, you had one thing that was, or a couple things that were fixed, and then you had a couple things that varied, which were the individual sessions. And so I'm going to read Brian's question real quick because I feel like we might answer on the slide. Brian asked, "My questions is with hierarchical models, when to use them? Panel techniques seem to apply to any type of user data for online users. Do people do this with large data sets?" Brian, I'm going to come back to your question at the very end of the live stream then, because I have a couple questions for you and we'll dig into them. But let me get back to the stream for now. And let me take out my webcam for a second. So what's interesting is that in the earlier part of the chapters, it seems like it was implied that the panel data had to be a sequence series of time steps. But in this example, it didn't seem like time was encoded. Maybe I missed it, but it was just that 4 sessions that occurred with the same person, and there wasn't a time element of when the sessions occurred. So similar to Brian's question, this is why I think a hierarchical model, for instance, would work well for this, because the hierarchy would be the individual and then the 4 sessions that they particularly tended to have. The full results and whatnot were in the book. It was a really long table, so I didn't find a good way. Well, let me bring it up. So let's just do it that way, because we have the internet. We can do these things. Nope, not my book. So what was interesting was, and I strongly encourage you to read this, is that Brian shows the results with 3 different models. So he took the same data set and then he modeled it 3 different ways to then come up with a whole bevy of conclusions. And I think this is an interesting one to point out, because I feel like a lot of times people feel like they're not biased, but one data set, one best model, and then one set of conclusions. But I found it quite interesting that in this particular case, he used 3 different model structures and 3 different estimators to then come up with a series of conclusions that reinforce each other. So I think highly encourage you to read this, dig into it, ask any questions in the discourse if you have any. But to finish off the slideshow, we alluded it to this at the beginning, but it's important to bring up now, is there's really strong assumptions you have to make. In the causality, in caveat 2, let's start with that one first. You really have to make the assumption that the fixed effects are fixed. The whole model structure is based off of this. So if the fixed effects change for some reason, and you assume they stay constant, your inference is probably not going to go well, even whether it's causal inference or not. But the interesting part for just causality was he talks about reverse causality. So with the police example, he brought up that crime is a function. Well, police spending is a function of crime. So if you're trying to estimate crime as a function of police spending, it's going to be particularly hard because the DAG closes in and on itself. So this is a similar topic that we've talked about in previous chapters. Is that when doing causal inference, how strongly can you make assumptions on the DAG? It always seems to be a lot of expert knowledge, and it seemed to be the case in Scott's as well. So same conversation that we've had numerous times now. It seems like the DAG is really important, and you have to what am I trying to say? You have to really stand by your DAG. So you have to really think about your DAG and justify what it's going to be to then justify the type of technique that you have used. All right, so that is it for the technical portion of this live stream. Let me try and get to Brian's question again, and then we'll talk. We'll close out at the end. Brian says, my question is when to use hierarchical models. Panel data seems to apply to any type of user data for online users. Do people do this with large data sets? So Brian, I'm gonna answer the first part of your question, but I need clarification for the last part. Is when you say do people do this with large data sets, do you mean do people use panel estimators with large data sets, or do people use hierarchical with large data sets? And then I will, while you think about that, let me answer the first part. So hierarchical models can be used anytime that you naturally see hierarchy in your problem. So if we take your example of user data for online users, let's say we wanted to get, so you guys are online users right now, right? So you guys are on my live stream using a platform. A hierarchy, for instance, could be we want to estimate the amount of users that are going to show up for different live streams, okay? And in my case, a hierarchy might be I'm a hierarchy because there's me, and then there's all the individual live streams that we've done as part of this book club, and then another hierarchy could be that I'm in North America, for instance, or a hierarchy could be that I'm streaming in this time zone. So in this case, there's a natural hierarchy of users that are streaming, users that are in North America, and then users like myself who are individual units. You could do those as a flat level as well, where none of them affect each other. But in this case, if you believe that there's a hierarchical effect from one to the other, then that would be the case. Sweetgreen, for me, it was pretty obvious there was a hierarchical effect because the region strongly affected the customer, right? Like where they live probably has a lot of correlation with their salary. So it didn't make sense to treat each restaurant as an independent unit. And I didn't want to just fix the New York effect to be the same for all the restaurants. So in a Bayesian setting, I could make New York a hierarchy so it could have its own distribution, which then meant each restaurant would then share information but not be tied to the same coefficient. So that was the case for hierarchy. With that particular setting, in my book I have a chapter on hierarchy where I talk about restaurant sales in a similar manner. So similar to, I believe, everything that we've seen in this book, it's just a matter of justifying that the model that you've had, and then just sort of running inference. Okay, so the second part of your question is, do people do this with large data sets? So I think there's two things that are going on here, which I would say. I'd say one is I think people are biased to using it on smaller data sets because it maximizes the amount of information that you... It sort of... I don't want to say maximizes, that's a strong word, but it definitely leverages information across groups. So if you have a very small group, but you have other groups that are quite large, hierarchical models help share information from the larger groups to the smaller groups. So that's one reason why you probably see them a lot with smaller models. The other thing that I think is happening though is, for better or for worse, some of these Bayesian methods like MCMC are really slow when there's millions and millions of data points, or can be slow. They're getting much, much faster. But in the past, they were slow. So I think when people had millions of data points, they weren't using them as much, and perhaps there wasn't a need for it. I will say, I don't know how much I can say about this because I work for Google, but I can assure you that there are certain cases that I've seen where there's a lot of data, and Bayesian methods are used. I don't know whether hierarchical methods are used, but can confidently say that there are people that use these methods for millions of users. I think there's just maybe a bias that there's a secondary bias, and that the research that gets published is not from large organizations, like large tech organizations. So you're seeing smaller sociological papers and not larger research. So to wrap that all up in a bow, some of this I think might just be observational bias. Just that you see papers from people that can publish papers, and you don't see the bigger things that are happening at some of the larger companies that I have now seen. Some of it may be slowness bias. So I will fully say some of the Bayesian methods were slower in the past, so you couldn't run them with millions of users. That is now changing with Jack samplers and TensorFlow probability and some of these newer algorithms and hardware. And then some of them, and this is the last one I don't know. Some of them might be when you have millions of users, you might not actually need hierarchy because you don't need to spread information across groups. I wish I could tell you how much proportion the answer was in each three, but that's my assessment from the information that I have. In terms of panel data that you'd also asked about, I've never actually used panel techniques in the causal world like this. So I don't know. I'm learning causal inference with the rest of you folks. So I don't know whether panel data gets used with tons and tons of people. But I'm actually really curious if it does. So if anybody sees a case where panel data causality occurs with lots of customers, let's say, let me know. I would be extremely curious to see whether this just gets used more in the smaller examples like Scott had just brought up, or whether it does get used with, like, let's say, an Amazon or some large company that does causal inference at massive scale. Thank you for the question, Brian. It's been a while since someone's asked a tough question, and I'm glad you're leading the charge here and throwing them in, making the best use of this live stream. All right. Any other questions? We got another question session coming up right after at the end, but with that, I'm gonna jump to the end. What's next is the diff and diff chapter. Really excited for this chapter. Diff and diff seems to be one of the more famous or widely quoted, or when I've seen widely used methods, just anecdotal experience. But our next session will be a little bit different. So I don't want to spill all the details now because I'm still talking to the person who volunteered, and I don't want to commit them to anything strongly. But we're gonna try I'll say more interactive format for the next live stream. I will talk to this particular person, and I won't name them, but if they want to name themselves, they can. About what it's going to look like, and what I'd say is look to the discourse to figure out a way to get how to get involved in this new one. So I don't want to commit to a time either, as I need to work it out with this other fellow. But we are certainly going to read the chapter. I would say try and read the chapter in the next 2 weeks. So you're well read, and then we will organize the session. So I've got the word that I can say what it's going to be, so I'll do that. I want everyone to give Chad a big round of applause. Chad messaged me and said he wants to take on a session of this live stream. And in particular, he wants to move it to a format which is where it's a much more group discussion based, like we were in a club together. And I have to say, I'm really, really excited for this. I've always appreciated you folks showing up to Livestream and letting me talk to you. But I'm really thrilled to have a more interactive session with you folks coming in. So Chad and I will work out the specific details, whether it's on Zoom. I have to talk to Chad about whether we can use Restream, but we're going to figure out the technological details. We'll figure out the best time. It's got to work for Chad because he'll be the one leading it, but that's what we're going to end up doing. So again, everyone to be sure to give Chad a big round of applause as he is leaning into this book club concept, and I'm so excited. All right, the last slide I'll just show it to you, but it's quite more. It's a live Q&A. So I see a bunch of messages came into the chat. Let me read through them to make sure that they're there. Lars says, I would look into popular diseases. There's lots of people's. I'm actually, I'm more and more curious. I feel like COVID, while it's a bad thing for the world and people in general, it's certainly become an extremely hot research topic because it's very rare times has the whole world mobilized to collect the same data at the same time and been afflicted by the same thing at the same time. And clearly it's an event that we really don't want to be flat-footed on as a society ever again. So I'm curious if things with like COVID and things like that, whether more of these like panel data estimators and whatnot will come up. So a good example that I've not seen any research, but I'm like curious about is if like panel data estimators will be used for long COVID, for example, right? Because long COVID is like the pandemic within the pandemic. These people have now been treated with COVID, whether they liked it or not. And over time, we'll see what happens to their symptoms and their illnesses and things like that. So I'm quite curious to see, for instance, what would happen with that as large mix of diseases. Brian says tracking users and modeling them longitudinally makes sense, especially because A/B tests rely a lot on independence assumptions, but you're measuring the same users over time. Yeah, I agree with you that it's this is actually something that's becoming more interesting to me as well, and I think actually interesting to a number of different companies. It seems like analytics version 1, quote unquote, was just putting everybody into a big randomized bucket and not really caring which user was which. But more and more companies seem to be tracking on like per user or per event time basis. I'm seeing, for instance, Sean Taylor is working at this new company where they seem to be doing just that. So these longitudinal studies for individual users over time, but at scale, seems to be a trend that I'm noticing and am extremely curious about. In particular, the reason for that as well is that in previous chapters, we talked about average treatment effects and things like that. And if you take the group as a whole, you get the average. But there's more and more questions and thoughts about what happens on the edges of the distribution, right? So not just what happens to the average user when you treat them. So if you make a discount, does the average user use more or less? But like what happens to the top user, what happens to the bottom user, what happens to individual users, and much more exploring the heterogeneity within a group rather than the homogeneity of an entire group together. So super interested in that as well. It's another reason this panel data topic was quite interesting to me. So I'm glad you brought that up, Brian. Rahul says, we have panel data and use hierarchical models for A/B testing for about 600,000 users. Rahul, I would love if you posted more about that in the discourse. I actually am really curious what you're doing. Would love to hear more about the things. Yeah, I'm just really curious. I mean, I'm almost curious about this stuff. So please post whatever details you can. If you have case studies or whatever information or white papers you have, please share that in the discourse. I really want to understand that as well. Chad says no problem to mention it. So I see everybody thanking Chad and everyone using the hand clapping emoji. So yes, Chad and I will get back to you and we'll share those details in the discourse. Just know on this, you guys are here, so I want you to hear it from me first. I think there'll be limited seats because it's a live session and we probably can't have 100 users in at the same time. So be quick to sign up when you see that post come up. Rahul says, I believe it's important to model the data generation process correctly in order to draw causal inference. with valid uncertainty intervals. So Raul, this is an interesting one because as Bayesians, I think, well, as me as a Bayesian, I would say, it makes sense to talk about the data generating process. That's what matters. That's what's important. What's interesting is I've never seen Scott at any point in his book say model the data generating process. He more so takes the tact, and maybe this is an economics thing, of just drawing the DAG and stating your conclusions. So it never, I don't know, if he said it, I completely forgot, but I don't see him say data generating process and generative models quite as much as I do on the Bayesian side, or I've seen my fellow Bayesians say about that. It's very much centered around this DAG and the conclusions around this DAG. And you could say the DAG is the data generating process, but he never quite says that. So I'm always I'm always curious about this the terminology, but then also the mentality, right? Because the terminology is sort of representing a latent mentality. And I want to ask Scott, maybe this is something if I still can get him onto this live stream at the end, is whether the data generating process is important, or whether it's just that the DAG is justified, even if it's not specifically the data generating process. But I'm really glad you brought that up. All right, I don't see any more questions here. This ended up being a full-length live stream. Actually, I thought it was going to take 20 minutes or so, but we're now at the end. Anything else that folks have a question about or want to chat about? No? Okay, so I'm going to say one last thing, and no immediate action needed, or that's a very corporate speak. You don't need to do anything right now, but we're very close to the end of this end of this book. We've only got a couple chapters left. We've got diff and we've got synthetic control, and we're pretty much over. So by actually kind of right on time, by the end of this year, I think we'll be done with this particular book club. I've had a lot of fun here, though, and I'd be really curious if you folks enjoyed it as well. So I'm gonna through some mechanism, I'm gonna ask. Actually, maybe we'll just do it on Discourse. I'd love to hear from you folks if you'd like to do another book club next year, and any changes to the format or anything like that. If you would like a book club, and then also just what book we would like to do, whether it be a more statistics or causality book or a programming book or something like that. But this has been great. I want to make sure we keep it going, and I want to plan ahead a little bit rather than lose the momentum at the end. So let me know. With that, I have nothing else, and I see nothing else in the chat. So I think we are good for today. Read the diff and diff chapters. Read the diff and diff chapters in the next 2 weeks, which would be in this clock, November. Can I count? 1, 2. Yep, November 20th. So just get prepped for November 20th, but Chad and I will come up with a specific time to have this more interactive session with you. Thank you, everyone. Thank you, Brian, for having studying stats in Social Circle. I agree. I love studying stats with people, and luckily the internet makes that easy. And I will see you folks on the Discourse and at the next session. All right. Enjoy your Sundays.